k times k minus k times k times k is equal to 150. How do we find the value of k? Without further delay, let us begin. Solution. We have k times k minus k times k times k equal to 150. K times k could be written as k square minus k times k is simply k to the power of 3 equal to 150. This implies that k square minus k cube minus 150 is equal to 0. So we have k square minus k cube minus 150 could be written as 125 plus 25, close the bracket, equal to 0. So we have k square minus k cube minus, we can also rewrite 125 as 5 raised to 3 plus 25 could be written as 5 square, close the bracket, equal to 0. Let's continue. This means that k square minus k cube minus times 5 cube, that is negative 5 cube, minus times 5 square, that is minus 5 square, equal to 0. Let's proceed further. Now, let us rearrange this equation. K square minus 5 square minus k cube minus 5 cube is equal to 0. Good. You will see that we can put these two guys in brackets. So we have k square minus 5 square. Also, from these two guys, it is very possible to factor out the negative sign. Doing that, we have minus into k to the power of 3 plus 5 to the power of 3 equal to 0. Let's continue. First, recall that a square minus b square is equal to a plus b times a minus b. This is just a difference of two squares. Also recall that the sum of two cubes, a cube plus b cube, is equal to a plus b times a square minus ab plus b square. So take note of these two properties. First, applying this property, a square minus b square, to this guy, we are going to have k plus 5 times k minus 5 minus, applying this second property to this sum of two cubes, we are going to have k plus 5 times k square minus 5k plus 25 equal to 0. Let's proceed further. What do you notice here? You will notice that k plus 5 is common. I can pull it out. So doing that, I simply have k plus 5 into k minus 5 minus this k square minus 5k plus 25 equal to 0. Let's proceed further. So we have k plus 5 into k minus 5, just drop the brackets, minus times k square, that is minus k square, minus times minus 5k, that is plus 5k, minus times 25, that is negative 25, equal to 0. Let's proceed further. So we have k plus 5 times, we have minus k square, k plus 5k, that is 6k. So we have plus 6k, minus 5 minus 25, that is negative 30, equal to 0. Good. Let's continue. This means that k plus 5 is equal to 0, or minus k square plus 6k minus 30 is equal to 0. From this line, it is obvious k is equal to minus 5. This is the first solution. Now, let us solve this quadratic equation. First, we need to multiply both sides by minus 1. Multiply by negative 1. So we have k square minus 6k. This is 6 plus 30 equal to 0. This quadratic equation can be solved using quadratic formula, which is k equal to minus b plus or minus square root of b square minus 4ac over 2a. I'm very sure you are aware of this property. That's the quadratic formula. From this equation, a is equal to 1, the coefficient of k square, b is equal to negative 6, this is 6, and c is equal to 30. So what we have to do now is to plug in these values into this. So k equal to minus b is negative 6 plus or minus the square root of b square, that is minus 6 all squared, minus 4 times a is 1 times c is 30. Everything divided by 2 times, what is a? A is 1. So we have 1. This means that k equal to minus times minus 6, that is 6, plus or minus the square root of minus 6 all square is simply 36 minus 4 times 1 times 30, that is 120, divided by 2 times 1, that is simply 2. Let's continue. So k is equal to 6 plus or minus square root of 36 minus 120, that is negative 84, divided by 2. K equal to 6 plus or minus, we can rewrite square root of minus 84 as square root of 84 times square root of negative 1, divided by 2. Let's proceed further. K equal to 6 plus or minus square root of 84, but we know that from the complex number, square root of minus 1 is simply I. So you just have to replace this guy with I divided by 2. K equal to 6 plus or minus. I can actually simplify the square root of 84 further. We can write it as square root of 4 times square root of 21 times this I divided by 2. Very good. So k equal to 6 plus or minus. What is square root of 4? That is simply 2 times square root of 21i divided by 2. So let's continue. We have k to be equal to, you will notice that we can factor out 2 from this numerator. Doing that, we simply have 2 into what? That is 3 plus or minus square root of 21i divided by 2. Clearly, 2 cancels 2. We have k equal to 3 plus or minus square root of 21i. This is another solution. So, therefore, we can claim that the first solution that we obtain is actually k equal to negative 5. Let's call it k1. From this line, we can obtain our k2. K2 is clearly equal to 3 plus square root of 21i by considering the positive sign. Also, k3 is equal to, considering the negative sign, k3 is equals to 3 minus square root of 21i. So, these are the three solutions for this algebra question. We can actually verify the first solution. Let's verify this, which is k1 equals to minus 5 using the original equation. So, verify. The original equation is k times k minus k times k times k equal to 150. So we have to verify the first solution, minus 5. So when k is equals to minus 5, plugging it here, we have minus 5 times minus 5 minus, let's just open brackets here. That will be minus 5 times minus 5 times minus 5 equal to 150. This is our claim. Let's put question mark. Minus 5 times minus 5, that is 25. Welcome, you just joining. Welcome, welcome. So we have negative outside into minus 5 times minus 5, that is 25. 25 times minus 5, that is 125. So we have minus 125 because there is 3 minus here. So we left with 1 minus 125 and claim that this is equals to 150. This means that we have 25 minus times minus 25, that is plus 125 equal to 150. That's our claim. 25 plus 25, that is 150 equal to 150. You will see that the left hand side is equal to the right hand side. That means indeed the first solution is correct. Likewise, the complex solutions, you can confirm it.